How long you can survive in space without a spacesuit. If you ever find yourself exposed to the near vacuum of space, so long as you don't try to hold your breath, which would result in your lungs rupturing and thus pretty well guaranteeing that the incident would be fatal, you'll likely remain conscious for about 10 to 15 seconds, with perhaps half of that being useful consciousness. After that, you'll be fine as long as you're placed back in a pressurized environment within about 90 to 180 seconds. These numbers are based on both human accidents that have occurred and on experiments run on animals. For instance, in 1965, researchers at the Brooks Air Force Base in Texas ran a series of experiments on man's best friend. They exposed the dogs to 1/380th normal atmospheric pressure for varying amounts of time to see how the animals' bodies would react. In most cases, the dogs survived without permanent damage so long as the time frame was less than 90 seconds. Once they pushed it over 2 minutes, the dogs typically suffered cardiac arrest and died. During the experiments, the dogs became unconscious after 10 to 20 seconds, and they experienced simultaneous urination, projectile vomiting, and defecation, the latter two caused by gas from their digestive tract being rapidly expelled. Many of the dogs also experienced dramatic seizures. Some dogs ended up with a thin layer of ice on their tongues as the moisture in their mouths evaporated, cooling the tongue rapidly. Finally, the dogs' bodies themselves swelled to nearly twice their normal size, with researchers noting that they looked like an inflated goatskin bag. You might think from this there would be no way their bodies could recover without some sort of permanent damage, but in fact, as long as atmospheric pressure was restored before that 90-second mark, while the dog's heart was still beating, they all survived with no apparent lasting damage. So that's dogs. What about humans? Chimpanzees were chosen here as the guinea pigs. They did much better than dogs, with most able to survive for up to 3 minutes, with the record being 3.5 minutes. For those under 3 minutes, they not only were fine, but the researchers were able to confirm that their cognitive abilities, with one exception, were not damaged in any way. We don't just need to rely on animal tests, though. Enough depressurization accidents have happened over the years for us to see that the typical Hollywood version of being exposed to space isn't all that accurate. One of the first such accidents was when a technician at the Johnson Space Center in 1965 accidentally depressurized his suit by ripping out a hose. He remained conscious for 14 seconds. During this time, he remembered feeling the water rapidly evaporating off his tongue. Around the 15-second mark, other technicians started the process of repressurizing the chamber. He regained consciousness at around the 15,000-foot atmospheric pressure level, which was about 27 seconds into the ordeal. The only residual effect noted was that he couldn't taste anything for several days after the accident, though his sense of taste returned to normal within a week. On the other end of the spectrum, we have an incident involving a man who wasn't so lucky. According to a paper by Dr. Emmanuel M. Roth, Rapid Decompression Emergencies in Pressure-Suited Subject, published in 1968, it took about 3 minutes to repressurize the chamber the man was in. Once it was repressurized, he gasped a few times and then ceased to breathe. Efforts to revive him were unsuccessful. So it would appear, much like with the chimpanzees, the 3-minute mark is roughly the upper limit for humans. So now that we have a pretty good idea of roughly how long you could last if your full body was exposed to a near vacuum, what would happen if just part of your body was exposed? Say, your hand if you're trying to plug a hole in your spaceship with it. To answer that question, we'll look at 2 incidents where something like this happened. The first was an equipment malfunction during Joe Kittinger's leap from about 19.5 miles up on the 16th of August 1960. During his ascent, the following happened in his own words.
At 43,000 feet, I find out what can go wrong. My right hand does not feel normal. I examine the pressure glove. Its air bladder is not inflating. The prospect of exposing the hand to the near vacuum of peak altitude causes me some concern. From my previous experiences, I know the hand will swell, lose most of its circulation, and cause extreme pain. I decide to continue the ascent without notifying ground control of my difficulty. Circulation has almost stopped in my unpressurized right hand, which feels stiff and painful.
Upon landing,
Dick looks at the swollen hands with concern. 3 hours later, the swelling disappeared, with no ill effect.
His total ascent took 1 hour and 31 minutes. He stayed at the peak altitude for 12 minutes, and his total descent took 13 minutes and 45 seconds, so his hand was exposed to a near vacuum for quite some time without long-term ill effects. In another incident that occurred during STS-37 in 1991, the 8th flight of the Space Shuttle Atlantis, NASA engineer Gregory Bennett states,
"The palm restraint in one of the astronaut's gloves came loose and migrated until it punched a hole in the pressure bladder between his thumb and forefinger. It was not explosive decompression, just a little 1/8 inch hole, but it was exciting down here in the swamp because it was the very first injury we've ever had from a suit incident." Amazingly, the astronaut in question didn't even know that the puncture had occurred. He was so hopped up on adrenaline, it wasn't until he got back in that he even noticed there was a painful red mark on his hand. He figured his glove was chafing and didn't worry about it.
What happened to cause the mark was that his skin and blood sealed the small hole. The astronaut in question, which was either Jerry Ross or Jay Apt, Bennett never said which, suffered no long-term ill effects from a tiny bit of his skin being exposed to space for an extended time. As for how long that was from puncture to re-entering Atlantis, it isn't known, but for reference, the two astronauts spacewalked for a total of 10 hours and 49 minutes during the mission. Be sure to subscribe to todayifoundout.com's YouTube channel for more great videos like this, and if you enjoyed this video, please like it below. Thanks for watching.